All right, we're live. Welcome, everybody. Good morning. All right. So here's the warm up. We're solving for y. Can anyone help me out? Tell me what we do, please. I see a lot of you had the right answer. Langston, that's correct. Joshua, that's correct. All right, let's just take a look. We're going to add 2x to both sides. Because our goal is to get this y by itself here. So the 2x is on this side. Ooh, I don't want to add 0 to that side. I want to add 2x. All right, so we get y equals, these 2x's cancel, and we're just 2x. So y equals 2x. You can put plus 0 if you want, but it's not necessary. Here is this equation in slope-intercept form. All right. Remember, we're trying to get y by itself, so we want to get rid of the 6x and 2. Let's get rid of the 6x first. Six x's cancel, 2y comes down. Can't add 6x and 8 because they are unlike terms. Now we want to get rid of the 2, so we're going to divide both sides by 2. When you divide this whole right side by 2, make sure you divide the 6x and the 8 both by 2. So this is negative 3x plus 4. And these two equations are in slope-intercept form. This has a plus 0 if you really wanted to have it in slope-intercept form, but again, that's not necessary. All right, so why am I going over this? Well, we're going to learn the second method of solving a system of equations. So please have your notes ready. It's going to be a lot of notes. And be ready to ask questions if you have them. Hope and Langston, you can write it as y equals 4 minus 3x. That's fine. It's not in slope-intercept form, but I wasn't asked to put it in slope-intercept form. You were just asked to isolate y, so it doesn't matter whether it's 4 minus 3x or negative 3x plus 4. Okay. I hope that you guys are actually ready to learn today. You're motivated to take notes and pay attention, because if you miss out on today's lesson, you are going to be very far behind, which is one of the reasons I'm recording this. So please pay attention and be ready to ask questions when you have them, because this is a complicated process. All right. Today, we are learning how to solve systems of equations. By substitution method. All right, sometimes it's called the algebraic method, but it's called substitution as far as you're concerned. So let's first talk about what is a system of equations, and here's the problem that we're going to do. Y equals y minus 2x, y equals 2, y equals 2x, x plus y equals 9. So here is our system. All right, so why does it matter? What is it that we're actually learning? Well, you can think of this as a side note. I'm going to erase this stuff in a minute, but it helps me organize my thoughts. So what is the solution to, say, this equation? X plus 2 equals 10. What is X?
8.
No. Right. So this has a solution. We can simplify this to X equals 8. This is a one variable equation. There's only one value for X that makes this true. All right. Now, what if I did this equation? So this has one solution, X equals 8. What if I did this equation and I add a Y in now? How many solutions can you put in for X and Y that make this true? What can X equal? Well, X
2.
could equal 8 and Y could equal 2, or X could equal 2 and Y could equal 8, or X could equal 3 and Y
6. 4.
7. Right, so there's an infinite combination of values that we could plug in for this to make this true. There's lots of different X's and Y's that make this true. There are an infinite set of solutions here. So how many solutions are there for this equation here? Well, there's an infinite set. How many solutions are there for this equation here? Well, there's an infinite set. So independently, these equations can't really be solved. We don't know the value of X and Y because it can be a bunch of different things. However, if we look at these equations together, there's actually only one place or one set of numbers that solve both of these equations equally. Now, when we graphed these equations, when we solved graphing, that's precisely what we did. We found that ordered pair, that X and Y value that made both equations true at the same time. So what I'm showing you today is another way of finding that X and Y value that is going to make both equations true at the same time. Now, could we graph these equations? Yes, we could graph them. We could find out where they intersect, and that's going to tell us the solution to this system of equations. Now, what are the limitations of graphing? Yesterday, you guys did, was that you guys? Did you guys have a system of equations on your test yesterday?
We didn't have a test.
Oh, I'm thinking of my other class. Never mind. So what are the limitations of graphing? Well, here's the limitation. Let's say we graph them. Let's say this is 1 and 2. Let's say this is 1 and 2. Don't write this down. What if our system intersects like this? Here. Well, that's not a good example. Let me move this. Let's say it intersects here. Well, if it doesn't intersect at a nice point, you can see here that it maybe intersects. I really want to move this like right there. Okay. You can see it intersects at Y is approximately 1 point something, maybe 1.2, and X is approximately 1.3 maybe. We don't know. We don't really know what this point is exactly. Now, we could use a computer program to find that exact point, but by hand, this doesn't really help us. Also, there's another limitation to graphing this system. Well, what if it's not in slope-intercept form? Well, then we have to put it in slope-intercept form, and it adds an extra step. It makes it more difficult. So there are reasons that we learn more than one method. And the other reason is solving systems by substitution is the best way. It always works. No matter what your system is, you can figure out the solution using the substitution method. So this should be your fallback method. All right. Here's the general steps for a solving using substitution. Now we're going to use this whole page, so I hope you have space ready to do this. And write these steps down, please. The first step is going to be to solve for an x or y. We want to get x or y isolated in one of the equations. Okay, now, sometimes it's already done for you. It's already isolated, like it is in this system. So you can see here that my y is already isolated. So we can skip the first step. We don't need to solve for an x or y in one of the equations because it's already done for us. It's just set up nicely in this system. All right, so let's look at the next step. After one of the variables is isolated, you are going to substitute that variable into the other equation. All right, so what does that look like? We're going to take this y and what it equals. So y is the same thing as 2x, meaning they're interchangeable. Y is equal to 2x, so therefore y is 2x. So if y is 2x, that means I can replace this y here with 2x. So that's what we're going to do. We're going to take 2x and we're going to substitute it into the other equation for y. So let's do that. So we're going to write the equation. X plus y equals 9. Now, why am I putting parentheses around this y? Does anyone know? It's kind of a personal preference, but it's something that I always do. Do you guys know why I'm putting parentheses around this y?
To know you're going to plug something in.
Yes, exactly. I'm telling the reader, which is you guys or whoever you're writing your work for, or yourself for later on, I'm telling you that this y is about to change. It's like greasing the engine, all right? We're getting ready to do something with this. So x plus, now instead of y, what am I going to put in the parentheses?
2x.
Exactly. So I've taken 2x, which I know is the same thing as y, and I'm substituting it in for y in the other equation. So that's what I did. Now that I have done this, look at this equation and tell me what is now missing from this equation.
Y.
Exactly. And if we only have one variable in the equation, what can we do? Well, when there's only one variable in the equation, we can solve for that variable. We can find the value of x now. All right, so step 2 is done. We have substituted in what y is into the other equation. And our third step is going to be solve the equation, or the new equation. So let's solve this. So to solve this equation, we're going to combine like terms. X plus 2x gives me 3x equals 9. And then we're going to divide by 3. And we get x equals 3. So we've solved the equation. So now we know the value of x. X is 3. So now that we know the value of x, what do we still need to find?
Y.
Y. So that's going to be our 4th step. Now that we know the value of x, we're going to substitute back into the isolated equation. You can substitute it into any of the equations, but it's easiest to plug it back into your substituted equation. It's less work. So let's do that. We're going to take x equals 3, and we're going to substitute it in for x. And that's going to tell us what y is. So let's do that. So let's rewrite this equation. I'm putting parentheses around that x because I'm about to replace it with what?
3.
Exactly. So what it, and then the 5th step, I'm sorry. Did I substitute the 3 in? Yes, we're done. Okay, then the 5th step is to do what?
Solve for the new equation.
Solve for the new variable, right? Or solve for the other variable. So let's do that. Y equals 2 times 3, which is 6. And we're done. This is the entire process. So we now have our x value and our y value. And when x is 3 and y is 6, it fits into both of these equations. Now we're going to write our solution like this, as an ordered pair with x coming first and then y coming second. And next to that somewhere, you're going to write one solution. And you might say, well, how is it one solution if there are 2 numbers? What I mean is it's one point of intersection. There's only one x and y combination that solves for this system of equations. All right, now let's look at this real quick. Something that we can do that is optional is we can check our answer. I'm going to show you how to do that. So now let's check our answer. Check. I'm only going to do this once because it adds a lot of extra work to your process here. When you're checking your answer, you want to make sure that x and y fit into not only the first equation, but also the second equation. So you're going to write out your system again. Y equals 2x. And you're also going to write it out for the other equation, x plus y equals 9. And we're going to plug in 3 for our x's. And you're going to plug in 6 for your y's. And everything else stays the same. You're going to ask yourself, are these things true? Does 6 equal 2 times 3? Yes, this is true. This means that it fits that equation. Does 3 plus 6 equal 9? Yes, this is true. So it fits that equation. So this fits both equations. So it is the only solution that'll work for this system. I'm going to pause for a second for anyone who's still writing, and now's a good time to ask any clarifying questions for this problem. All right. Let's look at another one. Now, for today's purposes, we're really only going to be solving systems where one of the variables is already isolated. Let's do. All right, x equals negative 2y. And x minus y equals 9. We'll call this example 2. All right, so if we go through our checklist, and I hope you guys wrote the checklist down because it really does help you at the beginning of this process. What is the first thing that we should check for, or the first thing that we should do?
Solve for x or y, or see if one is already isolated.
Okay, is there a variable in this system that is already isolated?
Yes.
All right, which one is that, please?
X.
X in the bottom equation. So let's go ahead and just highlight that. So we know this is already isolated, so we can skip step 1. Step 1 is done. So now let's look at step 2. Step 2 says that we need to substitute the value for that variable, which in this case is negative 2y, into the other equation. So I'm going to take this negative 2y and I'm going to plug it into the other equation. Now, does this go in for x or does this go in for y? Which am I replacing it with?
Y.
No.
X because it equals x.
Right.
Oh, yes.
Right. So this is something that you have to get in your brains here. We're taking negative 2y and we're plugging it into this other equation, but we can't just willy-nilly throw it in there. We know that this is the same thing as x. It's not the same thing as y. Y does not equal negative 2y. That doesn't make sense, right? X equals negative 2y. So we're going to replace the x with that negative 2y. So let's do that. Let's rewrite this equation. X minus y equals 9. I'm going to put parentheses around the x because that's what's going to be replaced with this 2y. Negative 2y. Okay, so let's substitute that in. All right. That step 2 is done. We substituted it into the other equation. All right, now we need to solve this equation. Step 3 is to solve this equation for whatever variable is there. Now we only have y's, so that's what we want. If you get to this step and you have 2 different variables, you did it wrong. After you're substituting, you should only have 1 variable. All right, so what's negative 2y minus y?
Negative 1y. Well, negative y.
Negative y.
Nope. All right, so negative 2y, and what is the coefficient here?
-1.
Right, so what is -2 minus 1? Got to be careful when you're doing integer operation. That's right, Hope. Thank you. All right, so let's keep solving. Now we're going to divide by -3. And we get y equals -3. This is half of our solution. So here's our answer up here. So 3 is half of the solution. Now we need to find the other variable. Oops, 3 doesn't go there, 3 goes in for the y. Y is -3, geez Louise. Okay. Now we need to find x. So step 4, we are going to, what color did I use on step 4? Orange. We're going to take that -3 and we're going to plug it into our isolated equation. That's this one for, in this case, y. So let me rewrite this. X equals -2 times y. All right. So this really is going in for this y right here. All right, so let's plug it in. All right, that's step 4. And step 5 is to solve this new equation. So x equals -2 times -3, which is 6. And we're done. How many solutions is this?
1.
This is one solution. All right, now we could take 6 and -3, plug them into both equations, see if they fit, but we're going to skip that and you're just going to trust me that these are the correct solutions for this equation. All right, any questions? All right, y equals x minus 4. Here we go. Last example. And obviously this one's going to be more challenging. Y equals x minus 4. And -4x minus 6y. -4x minus 6y equals -16. Okay. Let's go through our checklist. First thing we want to check for, is there a variable that's already isolated? Yes or no?
Yes.
Yes, indeed. Usually there will not be, but for today, I didn't want to give you the really, really difficult ones. Today, all of them will be, I have that first step done. So here is our isolated variable. So we're going to take, for step 2, we're going to take what that equals, oops. In this case, y equals x minus 4. We're going to take this and we're going to plug it into the other equation for x or for y.
Y.
That is correct. We're going to plug it in for y. So let's do that. Let's write this other equation. Parentheses around my y because that's about to change. And now let's actually substitute it. And instead of y, I'm going to put x minus 4. Did I lose anybody? Are there any questions?
I was kind of confused on the like why did you circle the x minus 4?
Because this is what y equals. So whatever this variable that's isolated equals, that's what you plug in. So
Oh yeah, okay, I see.
in the
So
last,
multiplying -6 by x minus 4.
right, we're gonna have to do that. In the last problems, what y or x equaled was just one term. It was like 2x or like, well, I don't know, -3x. Now it's two terms, but it doesn't matter. Whatever's over here, that's what goes in for the variable. In this case, it's two terms, x and -4. So yes, now we're gonna have to solve this equation. For x, you can see there's only x's in here now. And in order to do that, we have to distribute, which we know how to solve these. We spent a lot of time solving multi-step equations. So we're gonna have to distribute this -6 to x and this -6 to -4. So be careful when you're doing that. So this is -4x minus 6x plus 24, right?
Yes.
Okay. And let's continue our process here. We're going to combine like terms. This is -10x plus 24 equals -16. We're down to a two-step equation here. Let's subtract 24. Am I moving too fast?
Nope.
Perfect. I got some no's in the chat. All right, -10x equals -40. We're going to divide by -10. And we get x equals 4. All right, so we now know half of the solution. X is 4. Let's now find the other half of the solution. So let's take that 4 and let's plug it into this equation for x. So let's rewrite this equation. Y equals x minus 4. This x is going to be replaced. Y equals 4 minus 4. Something's wrong. No, I'm right. Okay. And the last thing we're going to do is solve this new equation. Combine these like terms. And we get y equals 0. So our answer is 4, 0, and this is one solution. All right.
What was the second one?
What was the second step in our series of steps?
No, for the like one solution infinite. I didn't.
Well, there's 3 types of solutions. You did this in graphing. There's one solution where the two lines intersect. That's like this one. If we graphed these lines, they would intersect. There's infinite solutions. That's where the lines are on top of each other, right? It's the same line. And then there's no solution, and that's when the lines are parallel. We will get to infinite and no solution later. Right now, we just are learning how to use substitution method. Baby steps. Did that answer your question, Aaron?
Yes, thank you.
So for right now, they'll all say one solution. All right, let's get you at least 1 or 2 to practice before you guys head out. Let me see here. Let's do x equals y minus 4. Let's do this one. X equals y minus 4. And then negative 2x plus 3y equals 6. Okay, I'll give you 8 minutes. We're just going to do this one practice today. Tomorrow we'll have many more to practice. I'll give you this one. I'm going to give you 8 minutes to do it. Make sure you do all the work in your notes, and then I will show you the answer at the in 8 minutes. Okay, set timer. Okay, go. Langston, make sure that you're not, we're not solving for what. So Langston, you're rearranging the equations. You don't need to do that. Take what x equals and plug that into the other equation. Hope that is, I believe, incorrect. I'm not sure why you got that. Hold on. Chris, that's correct. Hope, I think you just, your first variable was solved incorrectly. So make sure it's not 10. It should be something else, I think. No. You plug that in. No, you should be solving for y first, right? Yeah, so whatever you got for y, look at that work and try it again. Joshua, that's correct. Lauren, that's correct. Mod, no, that is incorrect. So make sure you solve for y correctly. You probably did something wrong there. Yada, that's correct. Correct, Fru. Aaron, that's correct, but your variables are backwards. Turn them around. Terry, that's correct. Tola, you got y was correct, but then when you substituted the y back in, your x is incorrect. So leave y alone, just check to make sure you substituted it correctly. Aaron, yeah, that's good. Yep, that's it, Hope. Good job. Ahmad, I already talked to you, right? Okay. Did you figure out what you did wrong for the y? So what did you get for the new y? Okay. Take your time. 1 minute, kids. Okay, that's time. Tola, that's correct. Two times one. Oh, I see what you did, Hope. You forgot to distribute the -2 to the -4. That's how you got, you just left it as -4, and that's how you got 10. Okay, yeah. Okay, -2. take that and we plug it back into the original equation for y. Then we solve this and we get -6. So our solution is -6 comma -2. Very good job. Thank you guys for doing this. All right. Oh, okay. Okay, that makes sense, Ahmad. Alex, good job. That was correct. All right. Are there any questions about this problem? Okay, don't leave yet. I need to, let me stop this recording.